So for computer programming B, here's a bit of stuff that I found out. I haven't looked at this in a couple days, but after a little bit of testing, so last week we left off here. We copy and pasted some code from the walking turtle, because that code is very similar to what we want to do with the mouse. In walking turtle, it just moves upwards. We're going to try to get the mouse moving in a circle, but at the moment it moves, or we didn't get it to move up. And it might have been my mistake with my window sizes, but there should have been a run button there. The code is all right from last time's demo, but you needed to press like run or next. Okay, so if you pick step, right? If we keep clicking step, you'll see on the screen that it does progress forward, up. If you click run, it moves up, just like that walking turtle. Okay, stop, and then run it again. And then it will go back to its original position. Ta-da. Okay, so I'm not sure what happened last week. Perhaps the buttons stopped working, or maybe I just didn't see them because my screens are so small. Okay, so that's good. That's relief. If we think about trying to change the mouse's position, like let's say we wanted it to move right, because we're going to have to do this if we move around in a circle, we have to go change this idea. 90 degrees, or 0 degrees is up. If we add 90 here, like that, it should now be facing right. So let's give this a run. Oh no, attribute error. Int object, no attribute, circle plus 90. Oh, oops. I changed its shape. Wrong line. I want get next state. So its position, its heading is now the one that's changing. So self.heading, it was heading. So that was its initial position, pointing 0. Let's see. I think we can just add 90 here. Oh no. I think this is what broke it last time. So we got it to display, and then, like, if you remember from the very beginning, this is what ruins it. I think this is what I got to last time, which is why the run and the stop and the quit buttons all weren't there. So I may have to continue some of this demo through Visual Studio instead of using Replit. But let's see. All right, a couple more tries. Let's try to delete this. Yeah, this is where I got to last time. Whatever this error is from like the very beginning when distance learning started, this error like makes our Tinker stop working. The buttons aren't there. So let me do a quick swap. This thing is going to be Visual Studio, if I can find it. Alright, so I'll stop sharing this. Let's go and share this. Alright, you see a black window in front of you? Great. So this is Visual Studio. It's very similar to Replit, except everything here runs on your computer. You may consider downloading this. It's always going to work. And a couple things to know when you're like using an IDE like this in a Visual Studio. So to run this code, there isn't a run button, right? You'll have to type in down here in the terminal. I'm seeing that I should make my text bigger. Alright, no. Find my setting. Because even I have to like squint in a bit. So, editor layout. No, appearance. Command palette, open view. Preferences, settings. Yes, let's try there. Text editor. Screen reader, no, none of this. Font. 18. Alright, so that helps. I don't know if I can get my terminal to get bigger though. So what I'm typing out in here is Python 3. Python 3 catmouse.py. That's how you'll run your code. If you do regular old Python, it doesn't come with the Tinker module, and it's going to give you this error right here. So I can demonstrate that. It's kind of small, but what I'm typing in now is Python without the 3 at the end of it. Catmouse.py, that's the name of the file that starts everything. It says no module named Tinker. You type in Python 3 catmouse.py, and then you'll see that window pop up. Ooh. Okay, this is where it gets a little awkward. So I don't think you see the window in Zoom, do you? Because that's like a separate thing. Alright, so let me do this instead. I will share my desktop. Alright, now you see everything that I see, correct? Now you see the window that's here? So, since I was focusing on, oh, I should probably close this. Alright, since I was focusing on just on the mouse, I just put that gray circle there. And you'll notice in the lower left-hand corner, here's your run and your stop, your step buttons. Now if you press quit, it actually quits without an error. So that's nice. And where I left off in the demo, code-wise, which will be the same on Replit, is right here for the getNext.state. We're changing the heading. We want to try to make it move right instead of up. And that should be adding 90 to the angle. So let's see what happens. Okay, it moved for 1 second up. Oh gosh. Okay, let's run it. Now it just kind of vibrates in shape. You see that? So this is kind of awkward now because the action is, it still wants to move up just once, but then after it moves up, it moves 1 to the right, and then I don't know what happens from there. Let's stop. So it moves, that was a tiny movement right, that was a tiny movement down, tiny movement left. Okay, so it's moving in this kind of pattern. As you keep adding 90 to your self.heading, your vector is like initially up, then it goes right. When you add 90 again, it moves down. When you add 90 once more, it faces left. And so it moves in a square-like pattern. Let's try to make that a bit more obvious. Right here. Is it the radius I want to change? 10. Oops. Alright, let's see. I want to make the movement bigger. So mouse starts here. I think this one's the radius. No, that's the heading. Third thing's the radius. Okay. So if we go back to catmouse.py, if we wanted to keep going right, we can change this. Let's just make it a bit bigger. 100. See what happens. Oh, that doesn't really help. I did in fact change the radius, but not in the way I intended it to change. Let's make it 20 for the speed. Alright. So now it's a bit more obvious, like it's clockwise pattern. Kind of like your bouncing ball, actually. Okay. So that part's cool. Maybe we'll leave it at 10. Radius 20 is good. So now your initial direction, we can mess around with this one. We want it to face right in the beginning, so that's going to be 90. If you change your initial position without changing the, like, wherever direction it's heading, because right now we have it more like, this is what you do next. You're going to turn clockwise 90 degrees. So right here, since we want it just to move right, we delete that 90, or saying whatever your direction is, stay in that direction. Now we see, oh gosh, it moves diagonally. Oops. Why does it move diagonally? Okay, so I deleted self dot position. You're still going in this speed. You are facing the same direction. Circle still being drawn. Let me double check here. Speed of 10. Oh, that's supposed to look good. Let's see what happens again. There we go. Yeah, maybe I just ran my code a little bit funny, but it moves to the right. Sweet. And then for clarity's sake, if we change this to 180, we should expect it to move downwards. Although if we add to the speed, I'm thinking it's vectors, it shouldn't matter. It should, I think it should move downwards, but I wouldn't be surprised if it moved upwards, because we're adding speed, but I think the vector stuff will take care of that. Yeah, the vectors separates the magnitude and direction, so then the minus and the plus we don't have to worry about. The vectors takes care of that. 270. Save, run. It should move to the left. Sweet. 90, negative 90. I think it should run in the same way. Yep. Okay, cool. Nice. So that gives us a better command of our coordinate system that we're working with. Let's see. So we're kind of close with our try on changing the angle for the mouse over here, right? When we added here, right? Initially we had like add 90 here, thinking that that would help move it right. But because get next state gets repeated again and again, that led to 90 being like a right turn always. So if we save and run this code, okay, we run, it kind of goes in the circular pattern, but it constantly like turns to the right. If we make that smaller, like maybe cut it in half, perhaps its path will look a bit more circular. Okay, quit. Run. Step, 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 right? So then that kind of looks a bit more circular. Right, if I do this, it's a bit more obvious. If we had even like 10 degrees, we should see an even better circle being formed. Right? So that's nice. And so we're almost there in getting it to move. Well, it does move in a circle, and perhaps we want to have it move in a bit more precise circle. Now the turtle, and now the mouse moves in a circular pattern, or a fixed circular pattern. I'm like thinking if we can avoid the sines and cosines from like the idea that's mentioned in the assignment prompt. Because going over that's going to take some time for your head to wrap around, and I'm thinking, because we have similar results as of right now, whether or not we need it. And I think we do, because once we have the cat and the mouse distance from each other, I think that calculation you do need degrees on how far away it is, right? Or can we do like something like the distance formula? I don't think so. Or maybe we will. We'll see. Alright, so right now, yeah, so it does give us some comparisons to do, right? If you think about like in Pong collision detection, it was like comparing inequalities. Now to know if the mouse is in like the cat's territory, right? Like its vision or its like killing range or whatever you want to call it. It seems like we can't avoid this trig that occurs. So that'll take some time to work through. And so, what do I want to say? So based on that, like right now, what do I want to say? Because I'm thinking, although your position is changing and your like if you're moving in a circular direction, yes, the angle that you're adding on is this idea that I've coded up here, right? That you're adding just a little bit. Where's that? Here in mouse.y. And that's like certain components, if you think like the x component or y component of your vector, cosine, or the sine part. And then I'm trying to think about how does the position change here. Because it's not like a linear change, right? That should also progress in a... Like it's not always going to be like add one, add one, add one. Take a look at my notes. Okay. Yeah, okay, so it is a bit more complicated. So the angle part, we'll focus here. Angle. Position. And right now, our angle, wherever we start, we don't have that currently. So let's add that in. Angle. Self.angle. And here, angle equals self.angle. How is angle different than heading? Heading is where you're pointing, angle is the change, if that makes sense. Because like you think about making like a 90-degree turn, or like you want to go like 10 degrees, like you're pointing this way, and your turn is not so much 90 in the next coming one, it's like a little bit this way. And then you're going to be pointing in that direction because you'll add on that difference, like something like this, I guess, right? This is where you are, this is going to be your change, your new direction is going to be facing this way, and then your change is like that much more. And then that's like, imagine like a pinwheel almost, a circle with a bunch of tangent arrows to it. that's like the path of your mouse. So if we change it like this, then what we're adding on is not so much 10, but your difference, that angle. Where is it? Cat mouse. Let's say like here, I added it after the, oh, it's the very last thing. Okay, after the speed. So let's say right now we have that to be 10. It's like a 10 degrees turn, so visually that should look the same as what we had before. Run. Yeah, cool. But then, if we go to cat mouse and let's say we decrease it by like 5, save, step, run, we have a wider circle, because now you have to take more steps in order to continue or to finish your circular pattern. If we made it bigger, like 20, or yeah, let's go 20 then 90, because then the 90 is the familiar picture we saw before. Okay, it gets smaller, right? It takes just like a couple steps to finish your circular journey. Now if we put it 90 and we save, step. That's not what I expected. One more time. Save. Save. All right. Yeah, so then we have that like for like your square movement, right? So that picture looks familiar. If you look really carefully at the center, you can even see that square. All right. So this thing, if we want it to be really small, like 1, then we'll have like a near perfect circle. Too big. My radius is way too big. Yeah, you see it come back eventually, but it goes off screen. Perhaps we shouldn't make it 1. We'll leave it at 10. For now. Or maybe it's because our speed is like 10 meters per second when everything's scaled to like 1 pixel equals 1 meter. That could also be a reason why it like moved off the screen. Alright, maybe we'll just leave it there for now. Let's try something else. Let's change its position. Let's change this to be in the center and see that that works accordingly too. So now it should start 100 pixels over, run. Okay, sweet. You'll notice it occupies the right half of the screen as you are making positive 90 whatever degree turns. Okay, so we're here. So that's a little bit on heading. It's a little bit on angle. Looking at my notes. The change, we don't need that much, do we? Can we get away with this? I think we can. Alright, let's go. Okay, what's the next thing I want to mention? Let's see. Okay, let's run this once more. Run. I'm like staring at it and I'm like thinking, okay, where do we need to go next? Quit. Alright, so there's something about position, and I'm not sure I can describe it that well. Can I? Okay, so here's what I have in my notes. Position is wherever you're at. Plus the unit of your angle. I don't think this does anything different though. And then we no longer have a speed. Let's see what happens there. That doesn't seem right at all. As I float off the screen. Because now I'm not like turning, or is my angle not being updated? Oh, it is. Heading. Alright, one more time. Step, 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 step. Alright, let's go back. So now our position, well, this is like no different than what we had before. So is that it? I guess we can clean this up. So angle is here, the amount of, yeah, I'll copy and paste my current changes into a new replit and see that it works so that you can add on to it. Good question. The amount, so let me add a couple comments before I sign off and like tell you and pass it on to you. Angle represents the amount you are going to turn. New position is just like from walking turtle.py. Progresses based on what direction you are pointing, or you are pointing or hitting. The other changes we made is this angle. We added an angle attribute to represent how much we are going to turn. Catmouse.py also got updated. Now the mouse has an angle attribute. Okay, I think that should represent the changes. Let me run this once, save and run it once more. And then I'll post the link on Google Classroom. Okay, 9:52, sorry to keep you. Double check that this works. Gosh, I didn't save this code. So you all are good to go. Email me if you have more questions. We made some progress today. Yeah, there we go.